Lesson 13, graphing systems of equations. Systems would be plural, so two or more equations that have the same variable. Solution. Solution are values that make the equation true. It's where lines on the graph are going to intersect. So we'll be graphing a couple lines here today and finding that point of intersection to determine our solution. Now there's three things that can happen. One, the graph can be the same line. If that's the same line, you have a blue line on top of a red line. If this were to happen, this would have an infinite number of solutions because the line goes on forever and every single point touches. The case would be when you put your equations in y equals mx plus b form, they would have the same equation. So y equals mx plus b would be the same. The second situation that you're going to run into is when you have lines like this. Now these lines are parallel. They will never intersect. So the number of solutions is 0. Okay, you'll have the same slope in this problem, but you'll have a different b value, or your y-intercept. So same slope, but the b value is going to be different. Finally, the third situation that you would run into is when you have two lines that finally do intersect and you have that one solution. For this to happen, you have to have a different slope. A couple other terms that you'll run across is consistent versus inconsistent. Things are consistent when you have solutions. So when your graphs intersect at one point, or if you have the same line for an infinite number of solutions. When they intersect or touch, it's a consistent solution. Inconsistent would be when you have no solution, meaning the lines are parallel. So for the first couple examples, what I'm going to have you do is, without even graphing, determine if things have one solution, no solution, infinite number of solutions, and if they're consistent or inconsistent. Looking at the first example, we have two that are already in slope-intercept form, and I can see that the slopes are both the same, but they have a different y-intercept. If they're both the same and with a different y-intercept, the number of solutions that the system is going to have is none. They're not going to have any because they will not intersect. Those lines are parallel. However, you also need to state that it will be an inconsistent solution, meaning that they'll never intersect. Now the next example, you can identify that you need to put it into slope-intercept form. So the second equation, we need to get it into slope-intercept form. That's what we'll do first. First things first, taking care of the addition and subtraction portion. Now get y alone. In order to get y alone, we're going to divide everything by 2. Once I have them in slope-intercept form, I'm going to compare the two equations, and they're both the same. So the number, they do have solutions. They're actually the same line. So the number of solutions here would be infinite, and this would be a consistent solution. Next example, we're going to go ahead and actually graph them to determine the number of solutions, and when you graph them, you need to find that point of intersection. That would actually be your answer for how many solutions the equations have. So both of them are in slope-intercept form, so we'll use the slope-intercept form of graphing. Tackle the first one using the intercept of -1. From there we'd use our slope, so we'd go up 3 over 4, and this line needs to decrease. So I'm going to go up 3 over 4, put a plot. I could also go down 3 over 4, put a plot, use my straight edge, draw that linear line. Second example, plot my intercept of 4, and then I would go down 1 over 2. Make sure that line is increasing, down 1 over 2. You can keep using that slope, up 1 over 2. Construct that linear line, and we have found our solution. That solution there, you write it as an ordered pair, so my answer is -4, 2. Example 3, I want you to go ahead and pause the video, put those into slope-intercept form, graph them to determine the number of solutions. Alright, we put them in a slope-intercept form. Looking at the two graphs, you can see that both have the same slope but a different y-intercept. That should tell you right there that the lines will be parallel. So this would have no solution. So really, we wouldn't have to do anything else, but we're going to go ahead and graph it to prove it. There's equation 1. There's equation 2. And our answer there would be no solution. Last one, I'm going to give you a little bit of a word problem here, so we're going to have to come up with an equation for each of them. Example 4, Jake and Brad each open up their own savings account. Jake made an initial deposit of $200 and plans to deposit $20 a week. If he does $20 a week, that's what it's going up by. Therefore, that is your slope. That is that rate of change. Brad did not make an initial deposit, but will save $60 a week. Part A, write an equation that represents the amount of money in Jake's savings account. Now, I like to use X and Y because that's what we use when we graph. So I'm going to go ahead and define a couple variables here. So Y would be the money that we have in our account. X would be the number of weeks. Our X value would be written next to our slope. So for Jake's account here, we have Y, his total money. He saves $20 per X, or $20 per week, and he made an additional deposit of $200. For Brad, you would have Y equals 60X, and he did not make any deposit. So we're going to go ahead and sketch the graph. The idea when you sketch a graph here, try to use as much of the graph as possible. Label your axes. X is talking about weeks, Y is talking about money, and this is all talking about savings. 3 simple points there. Now again, use as much of the graph as possible. My X values, I'm going to go up by 1s. Now remember, your intervals are counting every single line. It looks like I'm going by 2s, but each line is actually going up by 1. I'm going to go ahead and do my y-axis. My y-axis, I know I need to at least get up to 200 here, so I probably need to get past 200. So I'm going to go ahead and I'll go up by 20s. I'll go ahead and graph Jake's line here. He started out with $200 in his account, and then he goes up $20 per week, so up 20 over 1. When I go up, I'm counting by 20s, and when I go over, I'm counting by 1s. So up 20 over 1. I'm going to keep using that slope there. Draw that linear line, and this is what Jake's bank account looks like. Brad doesn't have an a y-intercept, so we'll put him at 0. He goes up 60, so 20, 40, 60 over 1. Plot. Up 60 over 1, up 60 over 1. Continue that pattern there. Up 60 over 1, and this is what Brad's bankroll looks like. So you can see that point of intersection, that would be the solution for the system. In part D, what it's asking for, in how many weeks will they have the same amount of money. So we're talking about the number of weeks here. We go up and we hit that line. It would take 5 weeks for Brad to finally catch Jake. This will conclude lesson 13.